Okay, welcome to the SAM Lab Introduction to R. My name is Brittany, and that's Jake.
I am on mute. My name is Jake. Hello.
And we're going to talk about, introduce you to R, the different types of applications you can use, and then we'll run through some examples. So what is R? R was originally developed back in 1993 as an open source data analysis program that has the capability to model, transform, and visualize data. It has been increasing in popularity in recent years due to it's openly available and for both Mac and Windows. For psychologists and statisticians, though, R is particularly useful because it contains a number of built-in mechanisms called packages for organizing data, running various calculations like TTests, and creating graphical representations of that data. An estimated 2 million people use R regularly, and so it's beginning to threaten mainstream statistical software programs like SAS and SPSS. Some of the big companies that use R are Google, Facebook, and the New York Times, just to name a few. One researcher at Google stated that R is really important to the point that it's hard to overvalue it. It allows statisticians to do very intricate and complicated analyses without knowing the blood and guts of the computing systems. But what are the benefits of using R? Well, there are several. The most important one, that R is completely free, which a lot of people like because it's very accessible. Secondly, R has over 10,000 packages for performing various analyses. These can be performing descriptives, looking at t-tests and regression, all the way up to very complicated analyses like structural equation modeling. Another benefit is that it's able to handle very large and very complicated data sets. It's also, the graphing capabilities are more appealing compared to things like SPSS or Excel. You basically build the graph from the ground up by selecting customizable colors, layouts, and the type of graph you want. Lastly, there is a large community of users that can provide troubleshooting advice. So websites such as Stack Overflow or our bloggers have forums where you can ask questions about issues that you're having with your code and get feedback on any issues that you might find. However, there are several drawbacks to using R. It requires all of your data to be stored in one place and imported there. So if you have really large data sets, this can be a potential issue. Also, learning R has a really steep learning curve. There's not any pull downs that you can use to perform different analyses. You have to learn or memorize the code that you want to do. And so sometimes it can be difficult to explain what the potential issues you have. And there are many ways to solve a problem, leading to this steep learning curve. Lastly, there's no dedicated programming support. So if you want support from R, you have to reach out to the community or read documentation on the various packages that you're using, which seems pretty intense for new users. But what does R look like? So this is a screenshot of what R looks like. Old R used to just contain the console down in the bottom left-hand side, but R Studio makes it a little more user-friendly with this interface with the code editor, workspace history, and the files. So the code editor is where, in the upper left-hand corner, is where you will write your code, and you can open save codes that you have. It's where all of the stuff that you make will be saved. The workspace history window in the upper right-hand corner will contain whatever data sets you've imported, objects you've created, and any functions. You can also click on data sets here to view them. There's also a handy little button where you can import your data set, and R can import CSV files, Excel files, SPSS, and SAS data sets. The File, Plots, and Packages window down in the bottom right-hand corner can show you any packages that you currently have installed or working with, any files in your current working directory. And then if you generate plots, they'll show up here as well. Last but not least is the R console in the bottom left-hand corner. It's where any output that you have will be printed. So if you run t-tests or regression, that output will be presented here. The downside is anything that you run here will not be saved. So if you're typing your code, make sure to put it in your code editor. So the two main packages we are going to be using today in this workshop is the psych package and the ggplot2 package. Packages are collections of functions that can be installed to perform different analyses. As we stated earlier, there are many different kinds of packages that can do many different kinds of things. If you have analysis you want to run, the odds are someone has already developed a package that can do the same thing. So the psych package contains many basic analyses that are used in the field of psychology. Specifically, when we go into the examples a bit later, we're going to run through some t-tests. The ggplot2 package is the most popular graphical package in R. As some examples of the types of plots you have your basic bar plots and scatter plots and histograms, but R can also plot geographical data as shown in the bottom left-hand corner with a regional demographics of Switzerland. You can also layer graphs on top of each other, as shown with the bar graph with the line graph on top of it. So it's important, these graphs are highly customizable and you can do pretty much anything you want with them. Now you have a little bit of knowledge about the basics. Let's practice and open our studio and we can run some code.
Awesome. So I am going to be guiding us through the coding portion of our workshop. I'm going to share my screen and then we will go ahead and get started. We're going to be doing a few basic analyses that are centered around getting you coding in R and getting you to a place where you feel comfortable running the analyses that you're used to in SPSS or other programs. The first thing we're going to do is load in the data set that we included as part of the workshop materials. So you could do this by typing in code, but RStudio, one of the great things about it is it provides a bit of a user interface for you to perform many of these tasks. So we're just going to go to File and Import Dataset. And this is an Excel data set, so we're just going to import it from Excel. So my data set is saved to where this opened up. Your data set might be saved to downloads or somewhere else. You're just going to need to find it and open it up. The code preview down here is essentially what it's running. And we're just not having to type it because we're using our RStudio to kind of shortcut it a bit. So we import our data set and we have a new data set. And now we're going to go ahead and name our data set something a bit more manageable other than x.samlab r. We're just going to name it our data. And I'm going to use this little arrow sign. You could also use an equal sign to the same effect. It's basically just saying, I want this to equal this, or I want this to be assigned this name. So in this case, our example data set is just going to be now named our data. You'll notice that over here in the data window, we now have two things. So we're not replacing the example data set. We're just creating a new name for it. If we wanted to, we could remove it from this space, but usually it's good practice to keep your old data sets as kind of like checkpoints as you're moving through analyses. Along with this, we're going to need to load in our first package. And to do that, we first need to install it. To do that, we can use the install package function. And you'll type it out, install packages. And in parentheses with quotes, and the quotes are necessary, we're going to install the package psych. You'll get some code down here and it's going to run it. After we install the package, we also need to load in our package. So we'll have it on our computer, but we won't have it in our session. To do that, we need to go to library, and This time we don't need the quotes. We're just going to call the psych package. So this will call in and load the psych package. So now we can use its functions. You'll get some output down here that it says that it loaded in. Along with this, there's a couple of syntax things to note. It's a bit hard to see with my current layout, but these hashtag symbols are making notes. So notes are an essential part of coding in R. They let you know what you're doing and give you, if you return to your code, it makes it much easier to figure out what you were doing at the time, and for anyone else who's looking at your code to figure out what you were doing. So include as many notes as is prudent, as you should or can, along with your code. So we'll just go over notes for syntax. The other syntax thing to note is this question mark symbol. This question mark symbol can be used to pull up your package information, function information, or really whatever else. So if we do question mark psych, over here, we're going to get the psych packages documentation from RCRAN. RCRAN is the repository where all of the R packages are stored. So this question mark is pulling up information on what the psych package is, and you could really use it on any amount of anything really that you come up with. You could use it on a function, you could use it on package, you could use it throughout R. So we now have our packages. We'll leave a note up here that says we're loading in the psych package. And then we'll go ahead and move on down to our first analysis. So we have a function from a psych package called describe, which is going to give us a bunch of the descriptives that we're used to, mean, median, standard deviation, that kind of stuff from SPSS or really any other statistics software that you use. So the function for doing this is just describe. So you can use the describe function to get descriptive statistics in R. To do that, you just run the describe function, put whatever your data set is in the parentheses, and you'll get some output down here with your descriptive statistics. So that's pretty easy, cut and dry. Along with that, we can go a bit further and do TTests in R. So the TTest function is actually from base R, but use the packages and functions from wherever you need to get the analysis you need, really. So we'll go ahead and run through a independent samples t-test right now. And to do it independent samples t-test, the t-test function is actually set up so that it's already going to run an independent samples t-test. So we just need to basically list the variables that we have that we want to run the t-test on. So maybe we want to know if there's a difference in the smoker groups from our data set, yes and no, if someone is a smoker, and how that affects their BMI. So we'll use our data, and this $sign is just going to basically say, I want this variable from the data set. So we'll do our data BMI, and we'll have a little tilde sign, which is saying this is being predicted by whatever follows. So our data BMI is being predicted by our data smoker. And then this will run an independent samples t-test, and we'll see that there isn't really any difference in this case. Something that I did want to note as far as other t-tests you can run this as a dependent samples t-test. The example data we're using doesn't really allow for that because we don't have dependent sample variables. So if you did want to do that though, you could just type in paired and set it equals to true. So that would just basically indicate to the t-test, the function, that it's these two variables are paired samples. Along with that, we also have a one sample t-test, which requires an additional argument. So arguments are the things that go within the function. One sample thing, one sample t-test. So the additional argument that we're going to have to include here is the known mean, or the mean that we want to test our variable against. So to do that, we'll go ahead and just see if our sample's BMI is different than a population BMI or a known BMI. So the argument would be mu, and we're going to set that equal to just 15 in this case. So we're just testing if our sample variable BMI has a different mean than this mu of 15. You run that, you'll get the information down here again, much of the stuff, same stuff that you'd be used to when you look at a t-test. Something to note here is that these are going to be running two sample t-tests, or not two sample, but two-tailed t-tests. If we wanted to make these one-tailed, we would just include another argument. One-tailed t-test. And that argument would end up being our, we would just set it equal to greater than, or the alternative hypothesis to greater than or less than, whatever it really needs to be. So we'll take this one sample t-test, and we'll add that in. So alternative hypothesis will just equal greater. If you wanted to see more arguments for the t-test, you could do the question mark, pull up the function, and see what else you could change about it. So that will run a one sample t-test looking at, is this our sample data greater than the mu? So that's pretty much all you have with t-tests. Then we have ANOVA. ANOVA is very easy to run in R as well. It just requires one function, and for us to code for, it's going to look a lot like the t-test. So we'll do a one-way ANOVA to start. The function for ANOVA in R is AOV, or which just is analysis of variance. So it looks like that. We're going to assign our one-way ANOVA a name of ANOVA 1, and we'll do AOV, and we're going to do our data and set that equal to our data. So this means that we don't have to do a the $ symbol to indicate what variables we want. It will know that we're doing variables from the data set, our data. So we'll do BMI, and that's going to be predicted again by Smoker. So we'll run that, and you'll see that there wasn't anything output down here. That's because we assigned it the name. We didn't ask for the summary or of the ANOVA. We're going to do that by asking for the summary. And we'll type in ANOVA 1. And we'll end up with our information from that one-way ANOVA. It'll look a lot like our independent samples t-test, but the ANOVA results are down here. We can make this more complicated by going on to a two-way ANOVA. It's more complicated in the sense of an actual analysis, but for coding, it ends up being pretty easy. We're just adding another variable to our ANOVA, literally. You end up just adding in the additional variable with an asterisk to say that this variable is interacting with that variable. And when you run that and do your summary, you'll end up with your two main effects, and then you'll end up with your interaction effect. So we have an interaction effect. We probably want to go ahead and do simple effects testing to see where this, where in the interaction we're having a significant, where the effect is significant, more or less. To do that, we have to first subset our data. This would be kind of like splitting the file in SPSS. To do that, we'll go ahead and do our data, and we'll do smoker no. I'll make a note, but this is simple effects testing. And to subset our data, we just use the subset function. And in parentheses, we'll select our data, and we'll say that we want smoker equal, we have to do 2 equal sign to no. And this will just say that we want to subset out some variable in our data and one of those groups. And after you do that, you'll have our data smoker with just smokers, no smokers. And then you'll also need our data smoker yes, so the other group. We'll subset out our data and set this one equal to yes. And now we have 2 additional things over in our environment. Then we will need to run an ANOVA on each one of these, and to see where in the interaction we're ending up with a significant effect. So we'll do ANOVA for smoker no here, and AOV, and then we'll do BMI is being predicted by sex again, with our data set this time equaling our data smoker no. And then we'll do that same thing again for smoker yes. And then we'll ask for summary of both. So we can see in smoker no, there's no effect between people who don't smoke and sex, but with smoker yes, we find that people who are smokers, there is a significant effect of BMI when considering sex. So that would be your simple effects testing, and you could do that down and down for 3-way ANOVA or 4-way or whatever you really need to do. The process would be the same. You just have to keep doing it in a stepwise fashion. So that's it for as far as we're going to take ANOVA. The last thing we will show you is simple linear regression. So the function for regression in R is LM, which stands for linear model. We're going to name our regression, and just run a regression to see if BMI is predicted by age. And again, it will look like it did with our t-test. We will do BMI and the tilde sign again with age, and then specify our data. And that will just equal our data this time. Oh, whoops, there we go. And then we'll ask for a summary of our regression. And we see that there's a significant effect of, or age is significantly predicting changes in BMI. So that's a regression in R. And the last thing you may want to do is make a plot, which is where ggplot comes in. So to make a plot using ggplot, we're going to first need to install ggplot and then call it, just like we did with our site package. So install your package, ggplot2, and then call it. Spelled library wrong. Okay, so there is ggplot, as Brittany showed a bit earlier with the examples, can do a lot. Regression doesn't really show it to its full effect, but if you wanted to just create a simple plot with a regression line, you could do that with 3 lines of code, more or less. We need to do ggplot, and then we need to specify our data. So our data, and then the AES, which is aesthetic. We're going to set our x-axis equal to age and our y-axis equal to BMI. And then from here, you're going to need to add a couple of additional arguments to end up with a scatter plot that also has a regression line. The first is to tell this plot, to tell ggplot that you want this to be a scatter plot. And to do that, you just indicate so using geom point with parentheses. And then you need to add one additional thing to get a regression line. To get your regression line, you need to do stat smooth, which is saying I want a line. And then to indicate you want it to be a regression line, you need to do method equals LM, which again is linear model. And color, we'll just set that equal to red. Color is expressed with COL. And then we'll run that, and we'll pop up with our plot over here. So you can see it's not the prettiest plot in the world, but it's also not the hardest plot to create in the world. We end up with our BMI on the y-axis, our age on the x-axis, and then we have this regression line going through the center, and then all the points throughout. This is, again, is just one very simple use of ggplot, and it can become much more complex and complicated. You could change the colors, you could change the names, you could really do so much with ggplot, and there's entire sections and seminars dedicated to talking about ggplot. But for right now, this is where we're going to end with our practice session of R. And before we end this workshop, I'm going to kick it back over to Brittany to talk a bit about extra resources and where you can go to get some additional help with R.
The resource we mentioned earlier was Stack Overflow, which looks a little bit like this. This ones are specifically R related, so you can see lots of people have asked questions and posed different answers. So if you have any problems with your code, you can go here, probably look it up, and they probably have an answer for you. There's also the RStudio Cloud. So RStudio Cloud has several different walkthroughs and primers that you can do all through your browser, containing basics of using R, tidying your data, all the way down to using Shiny to build interactive web apps. You want to get really fancy. There is also statmethods.net. It was developed by the same people who made DataCamp. This website is useful for, again, going through t-tests, but it also goes into correlations, some more multiple regression using power analysis, and they're all very detailed walkthroughs of showing you the code of how to do different things. Lastly, we also have the Paul Lakin website. So this one's a bit more in depth as you move forward. It has many different resources and books, online books that you can use to learn R, all the way from beginner to more advanced stuff like machine learning, text mining, things like that. Lastly, R also has a cheat sheet. Has cheat sheets available for things like ggplot that you can use that detail all the specific functions you can pick colors. So there are many resources there. These resources are all on our website as well if you want to look back at them, the Sam Lab website. So thank you for joining our webinar.